Hello, everyone. These are the answers, the evens to yesterday's worksheet. So please take a look at them and go back and retry problems if you got a different answer. And then always keep in mind, email me if you have any questions about a particular one, and I will get back to you. Pause the video if you need more time to look at this. But what we're going to take a look at today is multiplying radicals. So we're going to go through quite a few examples just because there's so many different kinds that we can be given. We have to take a look at some properties to help us as well. So as we multiply radical expressions, our goal here is to know how to multiply them using the properties and strategies that we have studied so far. Remember, at any time you need to copy things down, pause the video. But if you recall the multiplication property I introduced when we first started simplifying radicals, this tells us if we have the square root of a times b, we can separate this into the square root of a times the square root of b. Now this works both ways. A lot of times we may be given two radicals that are being multiplied together. That's not really helping us that way, so we could put it back together what's on the left side. Now something else I just want to take a look at is what we get when we multiply a radical by itself. So here, if we have radical 3 times radical 3, that's starting off over here, and I can go ahead and rewrite it this way as the square root of 3 times 3, which becomes the square root of 9, and the square root of 9 is what? 3. So we could just say a radical 3 times radical 3 will always just turn out to be 3. Let's try these next two, again showing that we're using this property and then going straight to a quicker answer here. So in this case, we could say this becomes radical 5 times 5 all underneath the radical, which is the same as radical 25, which is 5. So the square root of 5 times the square root of 5 just becomes 5. Or another way to look at this is if we took the square root of 5 and squared it, then the square root and square cancel each other out. Now radical 8 times radical 8, what do you guys think that'll just become? Just an 8. So really we could say a radical x times radical x is just going to become an x. So anytime we multiply a radical times itself, it's like we're squaring that radical, and the square and the square root cancel, and we're just left with what's underneath, what's the radicand is. So sometimes we have to use this property. Now, especially when we, next week when we get into dividing radicals, we're going to end up using this idea, this property. All right, so let's take a look at our first example. Now here we have 4 radical 3 squared. So what does it mean to square something? It means to multiply it by itself. So I could write it this way, but technically the parentheses aren't necessary. This is also saying 4 times radical 3 times 4 times radical 3. And then we can rearrange these. Keep in mind, these are not binomials, so I do not distribute here. Or what I could say is I'm squaring the 4 and I'm squaring the radical 3. But now that we look at it this way, I could rearrange them. 4 times 4 times radical 3 times radical 3. 4 times 4 gives me 16. Now if you remember from the last page, radical 3 times radical 3 is just 3. So we get 16 times 3, which turns out to be 48. So you guys try number 2 now. Use number 1 to help. Pause the video and give number 2 a try. Still pause again if you need more time. If not, let's go ahead and take a look at what you were getting. So what this is really saying, it's negative 3 radical 5 times a negative 3 radical 5. And again, I could put little multiplication dots in here and here. So now I could go ahead and just rearrange this. This is what's known as the commutative property. Anytime I add or multiply, I could rearrange the terms. I'm going to have a negative 3 times a negative 3 times radical 5 times radical 5. So negative 3 times negative 3 is a positive 9. Radical 5 times itself is just 5, so this gives me 45. All right, let's go ahead and take a look at 3 and 4. Now, if you notice here, the two radicals are being multiplied together. And right now, this is not helping us. So what we can do is multiply them together underneath one radical. And what it does is it turns into problems that we have previously seen and worked with. So what I can do is multiply everything together underneath one radical, so I could write it this way. 8 times 6 times x to the fourth times x. That's using that multiplication property. So now what I want to do is put the 8 and the 6, multiply that together to 48. And to be honest, I just want to leave the x's this way. Because if I multiply them together, I would get x to the fifth, and then I'd have to go back and rewrite them as x to the fourth times x anyway. So I'm just going to leave it this way. Now 8 times 6 isn't helping us to simplify the 48, so we have to think of something else. And if you recall, when we looked at 48, that was 16 times 3 times x to the fourth times x. So now I could circle the 16 and x to the fourth. So that comes out as a 4x squared, and I have a radical 3x left. So you guys go ahead and try number 4. This is 15y squared underneath the radical times radical 5y cubed. Pause the video to work this out and see what you come up with. Again, pause if you still need more time. But what we're going to do here is multiply, we'll say the 15 times 5 times y squared times y cubed. You don't have to show that step. I'm just showing you that we're putting everything underneath. So 15 times 5 is going to give us 75. And then here, I don't want to leave it like this, so I'm going to go ahead and put it back together as y to the fifth. And then I'll refactor this. So we have seen that 75 becomes 25 times 3, and then here I'll have y to the fourth times y. So we end up circling the 25 and then y to the fourth. So that comes out as 5y squared and then radical 3y. All right, let's take a look at number 5. If you notice, there's no variables. Now this one I do want to work out with you. Instead of multiplying what's underneath the radicals together, 12 times 21 becomes a really large number, a little bit too large to work with without a calculator. So this is what I'm going to do. Let's go ahead, and again, these are all being multiplied, so I can remove the parentheses. This just becomes 3 times the square root of 12 times 2 times the square root of 21. So I'm going to put the 3 times 2 first. Now the square root of 12, I'm going to go ahead and write as 4 times 3. And then the 21. Now 21 doesn't have any perfect square factors, but let's still go ahead and factor this here. So now I am going to get a 6 out in front. Square root of 4 comes out, so that's going to become a 2. And then I have radical 3. Now what I am going to do here is separate these to be square root of 7 times square root of 3. Again, I'm using that multiplication property. So out in front, I can multiply the 6 times the 2 to give me 12. Now, if you remember, if I multiplied a radical 3 times itself, what does that turn into? Just a 3, and then I'm just left with the radical 7. So I get 36 radical 7, and we kept the number small. We kept factoring down instead of multiplying 12 times 21 and then having to work with an even larger number. All right, the next several examples, we're using the distributive property. Notice there's binomials inside the parentheses for 6 and 7, so go ahead and copy down number 6. Here we want to distribute the radical 3. We're going to multiply by both terms inside. So remember, only when I multiply a radical by another radical can I multiply what's underneath. So this radical 3 times 4 radical 6. I'm not doing anything with the 4. That radical 3 can only get multiplied with the radical 6. So this becomes 4 radical 18. And a radical 3 times 2, the 2 is not underneath the radical, so that simply just becomes 2 radical 3. Once I do that, now I just check to see if I can simplify anything, and I can simplify the radical 18. So this becomes 4 times the square root. We'll use 9 times 2. Can't do anything else with the 2 radical 3. Circle the 9, so now this becomes 4 times 3 radical 2 plus 2 radical 3. So as soon as we distributed, what this turned into was everything we were doing yesterday with adding and subtracting. So I'm going to get a 12 radical 2 plus 2 radical 3. If you want to pause the video and go ahead and try number 7. All right, so let's see what you are coming up with here. So as I go to multiply radical 5 times negative 2 radical 10, the negative 2 is going to stay there. I can multiply the 5 and the 10 together to give me a radical 50. Plus, and since both the 5 and the 3 are underneath the radical, this will become a radical 15. Now the only thing I can simplify is the radical 50, so this becomes negative 2 times, this would become 25 times 2. 15 only has factors of 5 and 3, 15 and 1. None of those are perfect squares, so I can't do anything with it. I'm going to circle the 25. So now this becomes negative 2 times 5 radical 2 plus radical 15. And the last step is just to multiply the negative 2 by 5. So we get negative 10 radical 2 plus radical 15. Again, pause the video if you want to try number 8 on your own. But it's the same process. We just have to be careful because there's a variable in here now. So keep the video paused if you still need more time. I'm going to go ahead and go over this now. All right, so notice the 6x is under the radical, the 2 isn't. So this just becomes 2 radical 6x. But over here, both the 6x and the 2x are underneath the radical, so we can multiply 6x by 2x and keep it under 1 radical. So this becomes 12x squared. I can't do anything with the 2 radical 6x, so that just stays the same. But now this second radical I can simplify. The 12 becomes 4 times 3, and I'm going to leave x squared alone. Circle the 4, circle the x squared. Those are going to come out. We have 2 radical 6x minus, we'll get a 2. Square root of x squared is x, and then radical 3. All right, just a few more left to go through. So what we had for these 3 examples, we had just one factor outside a monomial being multiplied by a binomial. Our last 3 examples, we have 2 binomials being multiplied together, so we just have to distribute more. Go ahead and copy down number 9. Again, if you wish to try this on your own, go ahead. We just have to be very careful with our steps. It's very easy to overlook something or make a little mistake. So first, I want to multiply the 2 times the 4. So that's going to give us an 8. That's my first. Outside, I multiply 2 by radical 3, so then that's plus 2 radical 3. Inside, I multiply radical 3 by 4, or 4 times radical 3, so then that's plus 4 radical 3. And then last, I multiply radical 3 times radical 3. So you could write that as radical 9, or just know what we looked at the very beginning. Radical 3 times radical 3 is just 3. So combining my like terms, I can add 8 plus 3, 11, and then I can add the radicals together, plus 6 radical 3. Knowing that now, guys, definitely go ahead and try number 10 on your own. All right, so pause the video again if you need more time. If not, let's go ahead and check this. When I first multiply 5 times 5, we're going to get 25. On the outside, I multiply 5 times radical 7. They're both positive, so I get a plus 5 radical 7. On the inside, I have a negative radical 7 times 5, so it becomes a negative 5 radical 7, or minus 5 radical 7. Now here, I'm multiplying a negative times a positive. So a negative times a positive is a negative. Radical 7 times radical 7 should turn out to just be what, guys? Just a 7. So now I combine the 25 minus 7, which is 18. And then if you take a look, 5 radical 7 minus 5 radical 7, what's going to happen here? They're going to cancel. Now if you go back to the problem, don't the 2 binomials look almost identical, except one has a minus sign, one has a plus sign? So when we go to multiply those together, the inside and outside terms should always cancel. There's a special case that we refer to that as, and I'll go over that soon enough. Let's try one more. Again, pause the video if you wish to try this on your own. If not, continue playing. All right, so when we multiply 4 radical 2 times radical 2, this just becomes, the 4 stays here, and then radical 2 times radical 2 is just 2, but it becomes a 4 times 2. If not, you can write that as 4 times the square root of 4, which also still just becomes 4 times 2. On the outside, I'm going to multiply the 4's together, but one's negative, so I'm going to get a negative 16. Radical 2 times radical 6 becomes a radical 12. On the inside, I'm going to get another radical 12. It's positive. And then last, I'm going to get a minus 4, and then radical 6 times radical 6 is just 6. So my first term is going to become an 8. I can combine these two. A negative 16 radical 12 plus a 1 radical 12 will give me a minus 15 radical 12. And then I'll have a minus 24. I can combine the 8 minus 24. That'll give us a negative 16. Now we're good, but this radical 12 now has to be simplified. So I'm going to write that as 4 times 3. Circle the 4. So now my final answer, we'll get a negative 16. The 4 is going to come out as a 2, so 2 times 15 will give us a 30. So we get negative 16 minus 30 radical 3. All right, so you have two parts to your assignment. This first one is the new worksheet I'm giving you today. So multiplying radical expressions, only do the evens off of this. Now go back to yesterday's worksheet, adding and subtracting radicals, and do the odds. I'll have the post a PDF of the new worksheet multiplying radical expressions. Please let me know if you guys have any questions.